Okay, today we're doing exponential functions, and you should have in front of you notes that you printed off from Planet High School that look like this. This will really assist you taking notes today. An exponential function looks like this. Your x is now an exponent. That's what exponential means. B can be any number. If b is bigger than 1, we're talking about exponential growth, which means your graph will go up. Notice this point, this is your only intercept. It's 0, 1. It's usually going to be 0, 1. And also notice that your graph never touches the x-axis. It will never equal 0. No matter what you put in for these two numbers, you will never get it to equal 0. That is called an asymptote. The exponential graph never touches it. In this case, you could say it's the x-axis, or you could say it's y equals 0. That's that line, y equals 0. So if I graph the equation y equals 3x, again, this is the shape of my graph. It's going to go through the point 0, 1, and my asymptote is y equals 0. That line. Domain, can you guess what the domain is going to be? Goes left forever, goes right forever. All real numbers. Range is y is bigger than, not or equal to, just bigger than the asymptote, 0. You can transform these the way we've been transforming functions all along. You can multiply by a, which will stretch it. You can take x minus h, which will move it left or right, opposite the sign, or you can move it up or down by doing plus k. Whatever k is going to be your new asymptote. So check this one out. Y equals 2 to the x plus 1. I'm not even going to graph it. My domain is going to be all real numbers. It's going to go left forever, it's going to go right forever. My new asymptote is y equals 1, which means my range is going to be y is bigger than 1. That easy. Same thing, a little more complicated. This is your A. This is your H. This is your K. So this is going to stretch it. Using that chart in your notes or the page we just did, H is going to move it left or right. Opposite the sign, that's plus, so it's going to move left. It's going to move 3 down. My new asymptote is -3. My domain continues to be all real numbers. My range is going to be y is bigger than -3. You'll get a lot of exponential word problems. You just need to know this formula and what all those letters stand for. Write this down. AT is the amount after whatever time you're given. Little a is the original amount. R is going to be the rate, and T is going to be the time. Another vocab word you had, this is your growth factor, 1 plus R. So here's the census problem from your notes. In 1790, the population of America, I'm not writing all that, I'm going to say 4 million. That's your original amount. That's your little a. Original amount, 4 million, times 1 plus R. Well, here's your rate, but it's a percent. So it's really going to be 0.00203. Remember how you turn percents into regular numbers? And we're going to raise it to the t. Can you put that in your calculator as it is? No, you cannot, but if you changed it to x's, could you? I'm going to condense that. Yes, you can. You can put that in your calculator, so you can graph this function. Exponential decay, another vocabulary word. It's the same deal as growth. It's going to be b to the x. Your x is your exponent, except decay means it goes down. it can only go down if the b that you pick is a fraction. 1/2, 1/3, 1/4, 1/5, 6/5, no, 4/5. All of those will work. Will make your graph go down. We still have an asymptote. That hasn't changed. We still have the intercept. That hasn't changed. Domain is going to still be all real numbers, and your range is going to be y is bigger than your asymptote. Word problems with decay, you'll know to use this formula if something's going down. If something's increasing, you use the growth formula. If it's going down, you use the decay formula. Same thing, same variables, except instead of 1 plus r, it's going to be 1 minus r. And this is your decay factor. Now, in your notes, it tells you what kind of assignment you should be working on. So in class tomorrow or this morning, whenever you're watching this, that's what we're going to be working on today. I hope you took good notes.